In this lesson, we are going to review the concept of density using these questions. We are going to start by defining density and then state it as a unit. Now you know that density is defined as mass per unit volume. It is a ratio of the mass of an object to its volume. The equation which is associated with this definition is density is equal to mass over volume. That is why we say it is mass per unit volume, or you can say it is a ratio of the mass of an object to its volume. Now, since we are talking about the SI unit of density, then we can derive it by dividing the SI unit of mass, which is kilograms, by the SI unit of volume, which we already know is cubic meters. Written like this, or you can say it is kilograms divided by meters cubed, read as kilograms per meters cubed, or written in the scientific notation as kilograms, and then you leave a space here, you write meters, and then raised to -3. At this level, since you are just being introduced to physics, I will not expect you to use this equation here. The equation which I'll be using most of the time is this one here, but later on I will introduce you to the scientific notation. Let's look at the other questions in this lesson. In the first question, we are asked to show that 1 gram per centimeters cubed is equals to 1000 kilograms per meters cubed. So let's start with this first question. So 1 gram per centimeters cubed actually just means 1 gram you divide by a volume of 1 centimeters cubed. At this point, I want to convert the gram into kilograms. I need to remember that 1000 grams make 1 kilogram. So I want 1 gram in kilograms. So at this point, I can do what we refer to as simple cross multiplication. 1 gram times 1 kilogram, and then divide all that by 1000 grams. You'll observe here that the gram here will cancel out with the gram here, and I'm going to have 1 times 1 is 1, divide by 1000, all these kilograms. So 1 gram is the same as 1 over 1000 kilograms. Or I can say it is equal to 0.001 kilograms. So in the place of 1 gram, I'm going to have 0.001 kilograms. The next is to convert 1 centimeters cubed into meters cubed. Again, I need to remember that 1 million centimeters cubed is equal to 1 meter cubed. I just need to ask myself, how many centimeters cubed make 1 meter cubed? And I need to recall this, so that I can say that 1 centimeters cubed, therefore, is equal to 1 centimeters cubed times 1 meter cubed divided by 1 million centimeters cubed. And this definitely is going to give me 0. They are going to be 6 decimal places. 1, 2, 3, 4, 5, 6. Of course, meters cubed. and I've converted 1 centimeters cubed into meters cubed. So this 1 centimeters cubed is 0.0000001 meters cubed. And you can see I have my kilograms divided by meters cubed, which is this one here. Now I'm dividing this decimal number by this decimal number. When I look at this decimal number, it has 6 decimal places. So in order to get rid of those 6 decimal places, I will multiply the denominator by 1 million. And also the numerator by 1 million. Of course, it will make sure that all this and that cancels out to give me 1 meters cubed. So the denominator will be 1 meters cubed. And the numerator will be 1000 kilograms. And you can see 1000 divided by 1 is just 1000. Kilograms divided by meters cubed will be kilograms per meters cubed. And I've been able to show that 1 gram per centimeters cubed is equals to 1000 kilograms per meters cubed. At this point, I'd like to mention something which confuses very many students. Now, since students recall that 1000 grams equals to 1 kilogram, they usually think that there is some kind of mistake that has occurred here. They usually think that the correct way of writing it is 1000 kilograms per meters cubed is equals to 1 gram per centimeters cubed. Of course, this is the correct way of writing it. But when students are confused by this conversion unit, they would think that 1000 grams per centimeters cubed is the one which is equal to 1 kilogram per meters cubed. Many students usually think this is the correct way of writing this expression here. It happens a lot. But the correct conversion unit is 1 gram per centimeters cubed is equals to 1000 kilograms per meters cubed. Now let me try a different way of convincing you that this is the case. Think about a small cube, maybe of water, pure water, which measures 1 centimeter by 1 centimeter by 1 centimeter. This cube of water will have a mass of 1 gram. And therefore, the density will be the mass, which is 1 gram divided by the volume of 1 centimeters cubed, and we get 1 gram per centimeters cubed. 1 gram per centimeters cubed. That would be the density of that material. Now, I want you to think about a cube of water of this size, measuring 1 meter by 1 meter, again by 1 meter. The height would be 1 meter, the length is 1 meter, and the width will be 1 meter. So this length here will be 1 meter. But 1 meter is 100 centimeters. The width here will again be 1 meter. But 1 meter again is 100 centimeters. This is centimeters. The height is 1 meter. This height is again 100 centimeters. Now, think about fitting a small cube here. This corner here. Let's draw the small cube. The small cube, which measures 1 centimeter by 1 centimeter. And it has a height of 1 centimeter. So you ask yourself, if I were to arrange these cubes along the length of this large cube, how many of them would fit this length here, a length of 1 meter? Of course, if the length of one small cube is 1 centimeter, we are going to have 100 of them fitting here, arranged end to end in a straight line. We are going to have 100 of them fitting here. Similarly, we are going to have 100 of them here and also 100 of them here. So you ask yourself, if one of these small cubes has a mass of 1 gram and 100 of them fit here, 100 fit here, and 100 fit here, suppose we were to fill in this volume here with these cubes, how many of them are going to fit inside here? Of course, it's possible to tell that the number of small cubes that are going to fit inside here will be 100 times 100 times 100. We are going to have 1 million small cubes. 1 million small cubes. Now, if 1 million small cubes fit into this space, and one small cube has a mass of 1 gram, what will be the total mass of those small cubes? You will agree with me, it will be 1 million cubes times the mass of one of them, which is 1 gram, and we are going to have 1 million grams. That will be the total mass here. 1 million grams is the same as 1,000 kilograms, because I just need to divide by 1,000 here to get 1,000 kilograms. Let us go ahead and calculate this volume in meters cubed. The volume in meters cubed will be 1 meter times 1 meter times another 1 meter, which will give me 1 cubic meter. So let me go ahead and calculate the density of this material. It will be mass over volume. The total mass is 1,000 kilograms. Divide by 1 meter cubed. And the density is going to be 1,000 kilograms per meters cubed. Remember that the density of one of the cubes was 1 gram per centimeters cubed. Now I have calculated the density of this large cube, which consists of 1 million cubes. At this point, we would like to pause and ask ourselves, what is the meaning of density when we say that density is equals to mass over volume? The ratio of mass to volume of any substance. What does this mean? It means that if I've got a certain volume of a certain material here, if I divide its mass by its volume, I'm going to get density. Now, if I get a smaller chunk of that mass or that object, divide that very small mass by that very small volume, I'm going to get density, which should be equal to this density here. because it does not mean that when the substance is big, it has got a larger density, and when it is small, it has got a smaller density. No. If I get this small volume of this metal here, maybe let's say it is aluminium, which is 2,700 kilograms per meters cubed, and then I get a large chunk of aluminium. It may be uniform, it may be non-uniform, but it is made out of aluminium. Then this large chunk here has got the same density. So the density of aluminium when it has got a smaller volume and the density of aluminium when it has a larger volume has the same value. What am I trying to drive at? I'm trying to drive at this, that this density that we have calculated here for the larger volume of water is equal to the density of the smaller volume of water. Therefore, this density that we worked out here in these units, 1 gram per centimeters cubed, must be equal to this large volume here, 1,000 kilograms per meters cubed. I think that kind of discussion has thrown some light into your understanding of this concept of density. And more importantly, I'd like you to recall this. 1 gram per centimeters cubed is the same as 1,000 kilograms per meters cubed. And it is not the other way around, as most students usually think. But after thinking about this quantity for some time, you will find that you slowly begin to understand this concept. And you come to accept that actually 1 gram per centimeters cubed is the same as 1,000 kilograms per meters cubed. So let's look at this question here. The question number 2, where you're given that the figure shows a piece of wood in the shape of a cuboid. It has a mass of 300 grams. Determine 1, its volume, 2, its density in grams per centimeters cubed, and its density in kilograms per meters cubed. So let's go right ahead and do exactly that. The first one is to determine its volume. So because it is a cuboid, volume is equal to length times width times height. And of course, this one will give us 10 centimeters times 3 centimeters times 5 centimeters. And this will give me 150 centimeters cubed. In terms of marks, if I were to give you marks for having shown this working, I will give you a mark here for writing this expression for calculating the volume. And then I'll give you a mark here for showing correct substitution into the formula. And then the final mark will come here for showing this magnitude of the volume correctly by quoting the unit and a number. That is how you will get the 3 marks. Let's go to the second part that requires you to calculate the density in grams per centimeters cubed. So, since we've been given that its mass is 300 grams, and now we have worked out its volume, then it follows that density is equal to its mass divided by volume. Again, here I'm going to give you 1 mark. Its mass is 300 grams. Its volume is 150 centimeters cubed. And that definitely will give me 2 grams per centimeters cubed. So 1 mark, 1 mark, 1 mark. So I've been able to express the density in grams per centimeters cubed. The third part is to express this same density in kilograms per meters cubed. There are 2 methods you can use here. You can use this one here. you may recall that 1 gram per centimeters cubed is equals to 1000 kilograms per meters cubed. We have just shown this. So you ask yourself, how about 2 grams per centimeters cubed? You're going to do some multiplication here, cross multiplication. You have 2 grams per centimeters cubed. You multiply it by 1000 kilograms per meters cubed. And then you divide by 1 gram per centimeters cubed. Of course, the unit will cancel out as follows. And you're left with the kilograms per meters cubed. And your answer is 2 times 1000, you get 2000 kilograms per meters cubed. So again, for recalling this expression here, I'll give you 1 mark. For this manipulation of figures here, I'll give you another 1 mark. And finally, I'll give 1 mark here. Let's look at the second method of working out the same part. That is, we want to express this density in kilograms per meters cubed. The second method requires you to use the formula, which is mass over volume. This mass is 300 grams. 300 grams is the same as 300 divided by 1000 kilograms. And you're going to get 0.3 kilograms. That you're going to divide by a volume of 150 centimeters cubed. A volume of 150 centimeters cubed is the same as 150 divided by 1 million, and this will be in meters cubed, because we know that 1 million centimeters cubed is the same as 1 meter cubed. So how about 150? Simple cross multiplication should be able to give us this value, and this value will give us 0. It has 1, 2, 3, 4, 5 decimals. So 0.1, 2, 3, 4, 5 meters cubed. This will be the volume in meters cubed. So you come here and divide by 0.00015 meters cubed. And in order to get rid of this decimal, you're going to multiply by 1, 2, 3, 4, 5. You'll multiply by 100,000. And here you're going to multiply by 100,000. When you do that, you're going to get 0.3 times 100,000 divided by 15. And when we do that, you'll find this one will give us 0.3 times 100,000 will give us 30,000. And remember, this is kilograms and this is meters cubed. So it will give us 30,000 kilograms divided by 15 meters cubed. And when you manipulate this figure, you're going to get 2,000 kilograms per meters cubed. The second method appears a little bit longer, but it is one other way of working out the density of this substance from scratch, from something we call first principles, that is from the definition of density. The first method here was using a conversion unit, which I expect you to remember, this conversion unit. So you can either use this method or this method here to work out the density in kilograms per meters cubed.